Hello friends, Standard 11 Chemistry, Unit 2, Structure of Atom, Part 4. Last time we discussed about isotopes, isobar and isotons. In first part, we discussed about the fundamental particle of an atom, that is proton, neutron and electron. Proton and neutrons remains in nucleus and electrons circulates around the nucleus, and that part, planar part, is called orbit. So here nucleus that contains proton and neutron in the circular path, that is orbit, where electrons rotate around the nucleus, is the nucleus of atom. Now let's say the basic difference between orbit and orbital. These concepts is very most important for electronic configuration of an atom. So first of all, let's see what is orbit. Circular planar path of rotation of electron around the nucleus is called orbit. Here, what is orbital? The region around the nucleus, where probability of finding electrons is maximum, is called orbital. Region around the nucleus of atom where probability of finding electron is maximum, is called orbital. Now the next difference, the orbit shows the position of electron. Number one, position of electron, and its energy. And third, the distance between nucleus and electron, that means distance of electron from nucleus. Orbit shows position of electron and its energy and distance of electron from nucleus. Here for orbital shows probability of finding of electron. Probability of finding electrons. Third point, that orbit represented by n, that is equal to 1, 2, 3, 4, etc. n times. Here orbital represented by small s, p, d, f, etc. Then after, how many number of electrons are remains in orbit. So here number of electrons remains in orbit as per 2n square rule. As per 2n square rule, suppose here n equal to 1, that means 2 into 1 square, 2 into 1 equal to 2 electron. That means in first orbit maximum 2 electrons remain. Number 2, for n equal to 2, that means 2 into 2 square, 2 multiplied by 4 equal to 8 electrons. In second orbit maximum 2 electrons can remain. Number 3, 2 into 3 square, 2 into 9, that is equal to 18 electrons, and n equal to 4, 2 into 4 square equal to 2 into 16, that is equal to 32 electrons. So in fourth orbit maximum 32 electrons can remain. Here for orbital it is represented by SPDF. So for S orbital has one suborbital or subcell, and maximum each subcell can accommodate maximum 2 electron. So one subcell multiplied by 2 electron, that is equal to 2 electrons. That means in S orbital maximum 2 electron remains. Now for P orbital has 3 subcell, each subcell accommodate 2 electron. That means number of electrons is the first and second electron. That means here for P orbit maximum 6 electron. For D there are 5 subcells. Multiply by 2 electron, that is equal to 10 electron. And for F orbital there are 7 suborbital. Each subcell or suborbital can accommodate maximum 2 electrons. So 7 multiplied by 2 equal to 14 electrons. This is the very most important data for electronic configuration of an atom. So don't forget, number of electron remains in orbit and number of electrons remains in s, p, d and f orbital. In s orbital, maximum 2 electron, for p orbital maximum 6 electron, for d orbital maximum 10 electron, and for f orbital maximum 14 electrons. Now all the information about electron in an atom, it is stored in orbital wave function. Information about electron is stored in orbital wave function. Orbital wave function psi. This is the sign of psi. The probability of finding of electrons is directly proportional to the psi square. Probability of finding electrons is directly proportional to psi square, and psi square, that is probability density. Next point, the large number of orbitals are possible in an atom. So orbital can be distinguished by their shape, size and orientation. So here orbital are distinguished by their size, shape and orientation. First of all, let's see about size. Orbital of smaller size, that means there is more chance of finding of electron. There is more chance of finding electrons near the nucleus. And number 2, shape and orientation means there is more probability of finding of electron along certain direction. Shape and orientation means more probability of finding electrons along a certain directions. This is what is very most important. Here orbital of smaller size, that means more chance of finding of electron near the nucleus. Shape and orientation means more probability of finding of electron along certain direction. Each orbital is designated by three quantum number as small n principal quantum number, L azimuthal or angular momentum quantum number, and number 3 small m suffix l magnetic quantum number. Each orbital is designated by three quantum number: principal quantum number, azimuthal quantum number, magnetic quantum number. And to describe the electron of an atom in details, quantum numbers are used. To describe electrons of an atom in details, quantum numbers are used. That we will discuss in next topic. Thank you very much.